Hi, my name is François Leclerc, Product Manager for the GoScan 3D line of product. Now, I welcome you to this short video that is intended to help you do better demonstrations using your GoScan 20. Now, of course, you should know that all demonstrations are different and you'll need to adapt your speech to the level of your audience. Now, this video is intended for a new salesperson, but will also be useful to more experienced users as a refresh. Enjoy. As a first step, let's look at how the GoScan 3D technology works. All GoScan 3D systems use a combination of cameras along with a light projector, so they all have 3 different cameras. So when the trigger is pressed, the projector sends out a known light pattern onto object, and as this pattern hits the objects, it is going to be deformed by the actual shape of the object. Now, this deformation is going to be observed by 2 cameras on the scanner and interpreted as 3D data. This is how the data is created. Finally, a 3rd camera is going to capture the color images that is also referred to as texture. As it collects information, GoScan 3D also recognizes the shape of the object and uses that information to determine its position in space in relation to the actual object. This makes it possible for these scanners to scan most objects directly. When the shape of the object isn't providing sufficient information for positioning, it is also possible to exploit natural features. These are elements, recognizable elements of the texture that can be used to improve positioning. It is also possible to apply positioning targets directly onto the object and use these to improve positioning furthermore. This principle is called intelligent hybrid positioning and makes these scanners highly adapted to most situations. Pressing the trigger also turns on LEDs all around the cameras. Now, these LEDs provide light that is used to highlight the positioning targets and improve the detection of texture at the same time. Before we start scanning, let's take a look at some of the accessories that are available and that are going to help you in your demos. Positioning targets really are a key item into making it easier with the GoScan 20. They allow to compensate for a lack of positioning information. They also ensure accuracy, they improve overall tracking, and they also allow to resume at any known location. On top of that, they are easy to install and easy to remove. So don't be afraid to use them, and I can assure you, you won't regret it. Another very handy accessory for GoScan 20 is the 3D scanning turntable. Now, this acts as a support for positioning targets, so it lets you benefit from them without having to apply them directly onto your object, and it also lets you manipulate your part without having to get your hands in the scan. So it's extremely practical and very useful for medium to small size objects and should be used whenever possible. This is the GoScan 20 demo part. One is provided with each demo unit. It is a replica of an oil pump cover, and as you can see, it features a great level of complexity and is meant to be scanned directly using only the geometry of the object. It also features a texture element at the back so that you can demonstrate texture capture as well as texture positioning. Performing a scanner calibration is always something good to do once in a while, especially if you're traveling a lot with your scanner. So very easy to do, just aim at your calibration plate. So this will optimize the performance of your scanner as well as the color calibration and ensure that you get the most out of your GoScan 20. Okay, so our scanner is plugged in, our demo part is ready, but before we start scanning, let's take a look at some of the important settings in VX Elements. First of all, the project node. Here in this one, you'll find the capture texture button. So this is basically an on-off trigger for the color camera on your scanner. So if turned on, it will allow you to use texture either to capture the colors of the object or to use to refine the positioning of the scanner. If turned off, however, it will improve the capture frame rate of the scanner, leaving more bandwidth for the other 2 cameras. In our case, and for the purpose of our demo, we'll leave it turned on. Automatic shutter will constantly adapt the camera exposure to the colors of the object. It's good for objects with important color variations, but in our case we'll turn it off as our demo part is a rather uniform part. If setting the shutter values manually, setting your shutter towards lower values is going to be good for lighter objects or white colors. If setting it manually towards the higher values, it's going to be interesting for darker colors. In our case, for the demo part, we'll leave it as a default value. Next is the scan node. This is where you set the resolution of the scan or the size of the triangles that are going to be used to reconstruct the mesh. A finer resolution is going to provide you with more details, but the finer the resolution, the more data you will get and the more demanding it will be on your computer. So to scan something like our demo part, I like to use a resolution of 0.5. Next, the optimized scan mesh is something that smooths the data and keep the edges sharp. It's particularly interesting for prismatic parts, and for the purpose of scanning our demo part, we'll set it to the very maximum limit. Next, it's interesting to set a certain value for the remove isolated patch. So I'll set it to 20 here. So this will automatically remove unwanted data that's flying around your object. No need to use other parameters for now. We'll just click apply. Positioning node is where you have different options related to the positioning of the system. So in our case, we'll turn on the use natural features. This will identify recognizable elements of the texture that are recognizable and usable to improve the positioning of the system. Finally, the texture node. This is where you access options that are related to the texture. So of course, to scan our part in color, we'll click apply texture and we'll leave the values to default, as they're going to do a pretty good job with our demo part. If you wish to save time, you can always go to your configure menu in session parameters and select save current settings as default session parameters. This way you won't have to run through all these settings again for your next session. So we're now ready to scan, and before we start scanning, you should know that having targets applied onto your demo part is not mandatory, but is definitely going to help. So when you're ready, simply place your part onto your turntable and start scanning. When scanning a part, hold your arm steady and at the right distance and manipulate your part using the turntable. This makes it much easier not to get lost, and if you ever do get lost, go back to a known target location to resume scanning directly. When you're scanning, keep an eye on the distance meter located at the left-hand side of the screen. This device will let you know if you're scanning at the optimal distance away from your part. If it turns yellow and eventually red, this means that you're scanning too close to your part. And if it turns blue and eventually dark blue, this means you're scanning too far away from the part. Try to keep it in the green zone. This means that you're at the optimal distance. And there you have it. A very good quality scan made in no time, and what's actually great with VX Elements is what you see on screen is what you get. And once you stop the scan process in VX Elements, what you actually get is a single layer already triangulated mesh with texture already applied. So as you can see, texture quality is very good, and if I flip the part to show you the texture element in the back, you can see that the texture is very good quality, very crisp. Turning off the texture, I can also show you the surface quality. You can see it's pretty amazing, and I can also show you the wireframe here. Zooming in, really a single layer, very good quality surface. So if you're satisfied with what you see, all there's left to do is to click File and then save the mesh or save the session file. Or if you wanted to go back to your scan again and start scanning, you can simply hit the scan button again and add more data until you're satisfied with the results. So you might have noticed that we have some triangles here that are attached to our part and that we do not need. So a couple of things that we could do: we could go to Edit Scan and select them manually and delete them. But another thing that we can do is to use a clipping plane. So this is what we're going to do here. We're going to create one using the targets that were on our turntable. Just select them here. Make sure that our part is correctly oriented, and then we're going to make sure that we clip these triangles. Click the Apply button, and there you have it. A very clean and easy way to get rid of any surface that belongs to our turntable and get a very clean border all around our demo part. Demos rarely stop at the demo part, and chances are you'll be asked to scan something else. So this next segment contains tips and tricks on how to get the most out of your GoScan 20. Start by scanning the most of your part using your turntable. Pick your part and place it directly onto your working surface. Define a resume location and scan the bottom of your part. You can also flip your part onto your turntable, but remember to delete your turntable's targets in VX Elements before you start scanning again. If you want to get the most data when scanning an object and using your turntable, one of the good ways to do so is to tilt your scanner sideways this way. So if you want to do this, just remember to tilt it on the left-hand side, keeping the geometry camera at the very bottom. This is what will lead you to best results. If you're struggling trying to scan a certain area of a part for some reason and wish to understand why, you can always turn on the Show Slippage Direction from the Positioning menu. It will inform you when particular areas of an object are difficult to scan and show you where the ambiguity is coming from. Yellow arrows meaning an area is slippery but scannable, and red arrows meaning that the area does not provide sufficient information for positioning. Applying a few targets here and there will improve positioning and let you scan this area without a problem. Clipping planes are very useful when using GoScan 3D, as they provide you with a virtual limitation preventing you from collecting unwanted data. You may create as many planes as you want, just remember to have the planes normal pointing at the data you want to keep. You can also create them at any point in time in your scan process. As an example, you may start by creating a clipping plane on top of your turntable using the targets on it to create the plane. This will prevent you from capturing any part of the table and save you time at the reconstruction, as you will not have to compute the table surface at the end. When you're scanning an object that has edges and you're trying to go from a face to another, try to keep your scanner in the same orientation as the edge you're going around. So this would be good. This would be more difficult. So using this orientation will help you keep tracking when going from a face to another. One of the typical questions with GoScan is, which one do I need? What are the differences between the two? So GoScan 20 really is all about high resolution. Its smaller field of view allows it to capture even the finest details of object, and this also applies to texture, as it will provide you with a much crispier texture than the GoScan 50. GoScan 50, on the other hand, really is all about speed. Its larger and deeper field of view allows it to capture the shape of objects much faster than the GoScan 20. GoScan 50 is ideal for medium to large size objects with medium to low complexity. GoScan 20, on the other hand, is more for smaller, intricate objects, but can also be used on larger objects with the use of targets. Now, if you want to find more information about these two, remember that there's a document that's comparing the GoScan 50 with the GoScan 20 available online. Noisy surfaces are generally caused by an insufficient amount of data capture. This will show even more if you're using a finer resolution. Capturing more data will fix the problem and improve the surface quality. Since data is processed in real time, refining your data this way will not progressively increase the amount of memory required and eventually lead to a crash as it would with other competitive products. One of the typical challenges when doing a demo is, can you scan my smartphone? Now, smartphones are generally black, shiny objects, and they're very difficult to scan directly. One trick to do it would be to apply some spray powder on it, and this is definitely not recommended for a customer phone. A typical challenge encountered when doing a demo is, hey, you have a high-resolution scanner, can you scan this? Now, coins and keys will rarely lead to good results, and you should avoid to scan them as much as possible. Try to focus on your customer's application instead. Our triangular pyramids references will definitely be helpful when scanning with your GoScan 20. Supplied with 3D scanning turntables, they provide you with targets at a 45-degree angle. They will ease the capture process furthermore and provide you with best results. Be sure to use them whenever possible. So this concludes our video demonstration for the GoScan 20. Remember to keep practicing and keep an eye out for software updates. Now, I hope you have enjoyed this video and that it will help you do better demonstrations with your GoScan 20. Thanks for watching.